Welcome back, everyone. Wise Guy Wednesday this morning, and today we're circling around simple harmonic motion.
Easy for you to say. Of course, to explain all this physics fun is our favorite mad scientist, Matt Sellen from the University of Illinois. Okay, what do you have today?
Well, I've got a bunch of stuff. Now, let me remind you of the question that I asked at the very end of the last segment last week. So I said, okay, suppose you have two people on a swing, and the swings are the same length, and one person takes one step back, the other one takes two steps back, and you both start swinging at the same time. Which one gets back to their farthest back position first? And the answer is they both do at the same time. Because as it turns out, if you swing on a swing like a kid might, the amplitude or the size of the motion doesn't really affect how long it takes to go back and forth. In fact, even the size of the kid doesn't affect how long it takes to go back and forth. The only thing that determines how long it takes a swing or a pendulum to go back and forth is how long it is. So that's pretty interesting.
Okay.
And so we're going to talk about this today. This is called simple harmonic motion, and this idea that the amplitude of the motion doesn't affect the period or the frequency of the motion is central to this whole thing, and there's tons of things that behave this way. So I'm going to give you some other examples, and then in the second segment we're going to talk about resonance, which is how you can make oscillations really, really big.
Okay.
Okay. All right.
Let's make them big here.
That's right. Okay, and so a really classic example of something that oscillates up and down. Oh, let me just say that the person who got the answer right was Will Gibbons again from Catlin.
Oh, sure.
And this guy is amazing. He just turned 7 just a week or so ago, and he answers the question every single week.
All right.
And he's really good. And in fact, he knew something I didn't know. He knew that Galileo figured this out. He's an expert on Galileo. Okay.
Really?
Yeah. Okay.
Wow.
So it turns out that you have this kind of motion whenever the force that tends to want to make the thing go back to the original position is proportional to how far you stretch the thing away from the original position. So for example, if you have a mass on a spring and you stretch it away, the thing starts to oscillate up and down. And it has exactly the same kind of motion. If you have just a small oscillation or a big one, the frequency is the same, and it only depends on how stiff the spring is. If it's a stiffer spring, the thing will go faster. And if the inertia of the weight also matters, so if you have a bigger weight, the thing goes slower. So if I put 2 weights on this thing, you'll see that it oscillates up and down slower.
Right. Okay.
Okay, so this would be like, for example, in your car. You have springs on your car. The car is a great big weight on top of those springs, and the car can bounce up and down. Okay, this is another kind of pendulum called a torsion pendulum. It's just a wire that hangs down, and when you twist it, it tries to restore the position to where it used to be. And so this thing oscillates back and forth with a very well-defined frequency as well. If I make it oscillate with a much bigger amplitude, it still takes exactly the same amount of time to go around and come back.
And that's nothing special that you've done with that?
It's nothing special. This is simple harmonic motion. A wine glass oscillates if you give it a little tap. You get a nice sound out of it like that. Okay. Everything likes to oscillate. And in fact, I went to Menards and I got this plastic pipe and I stuck a bolt on the end of it. And this thing also, if I just let it go, oscillates up and down with a very regular motion. And so we're going to make these things oscillate very with really big motion in the end of the next segment.
In our next segment. Okay.
All right.
I'm dizzy watching all these things go around.
Take a second to let it all sink in.
Yes.
Fortunately, you'll be back.
Yes.
Well, stick with us. We'll stay with the baseball theme in our Wish You Were Here postcard.
Plus, it's a bird, it's a plane. Actually, no, that's a crate of eggs. But why are they falling from the sky in New York City?